Of course, other operational concerns relating to using Vansel were discussed.
We are now pumping twice, so we have added another whole set of mechanical devices that have to operate correctly, have to have power at all times during an emergency to get water up to Vansel.
Using Vansel would not change the number of booster stations pumping water in Fortuna. These stations contain multiple pumps to allow the system to operate at all times. During an emergency, the booster station at the source can provide water to Zone 1, but only to Zone 1. All other zones require at least 2 booster stations for water delivery from the wells. And for power, there is a backup generator at the source. In fact, I am told there is a generator for each booster station. 2 more are located on site at booster stations. However, the remaining are in storage and need to be transported to the booster stations when needed.
We would be delivering fire flows through the pressure reducing valves and pumping, or we would have to build the new gravity line. We have talked at considerable length in regards to pressure reducing valves. These allow us to move water between pressure zones. They are a very delicate and touchy mechanical system, and they are subject to pretty regular malfunction. They are probably one of the highest maintenance and most difficult to properly maintain facilities within the water system.
As for needing a pressure reducing valve, or PRV valve, in a memo, the city engineer stated that the city has identified the need for additional training, increased inspection, and routine adjustment and maintenance to ensure that all of the city's PRVs are reliably functioning as intended. You may have heard that PRVs close when they fail, thus interrupting the flow of water. However, I learned from an engineer at the regulatory agency that there are PRV valves that fail open, allowing water to flow. These are placed in a series so that the failure of one does not result in an unacceptable increase in pressure. Reducing stations may not be as common as booster stations, but they are common enough to be part of the regulatory agency's inspection form.
And to rely on check valves and pressure valves and so forth, to rely on all these things operating properly, I think really takes the simplicity out of a system that I think should be kept as simple as possible. Water behaves very predictably. Water flows downhill unless it's under pressure, until we start putting all sorts of additional complexities and so forth to perhaps make it not so simple. And I would hate to be the one, if there was a major fire downtown, I'd hate to be the one who made the decision not to put enough water storage in pressure zone 1 to fight a fire without all sorts of extra valves and so forth, because you don't have time to call the public works person who knows how to go up there and bypass a valve when a major fire is going on.
The water system also has a SCADA system, a computer system for monitoring and controlling some parts of the system. Highlighted on the schematic with purple squares is the telemetry, providing remote measurement and reporting information for the SCADA system. Up until the 1960s, the water system was simple. But that has changed over the last 50 years. It is no longer simple. The distribution improvements needed to use the Vansel Reservoir for Zone 1 storage will not greatly increase the complexity of the system. Indeed, the concerns regarding fire flow during construction of the new tank can be addressed with an additional gravity line. That pipeline will also eliminate the need for a new tank. The new tank is not critical or essential to the operation of our water system. Is it urgent?